This is the screencast for section 5.3, example 2. We're going to confirm the cofunction identities. Remember in section 5.1, you had those identities that said the cosine of pi over 2 minus theta equals the sine of theta, and the sine of pi over 2 minus theta equals the cosine of theta. Well, didn't you wonder why they wrote it pi over 2 minus theta, and why are they even equal in the first place? I mean, you know that the graphs look alike. Well, today we're going to actually prove that those two are equal. So that means you can't use the identity. You can't just say they're equal because they're equal. You have to show why they're equal. You have to prove it. So we're going to use the cosine of a sum and sine of a sum or difference functions to help us. On the left side here, I have cosine of pi over 2 minus x, so I have a cosine of a difference. That means I'm going to use the cosine of a difference formula. Cosine of pi over 2 times cosine of x, now plus the sine of pi over 2 times the sine of x. Cosine of pi over 2, I know, is 0 from my unit circle, times the cosine of x, plus the sine of pi over 2, I know, is 1. Also from the unit circle. 0 times cosine is 0, so I have sine of x equals sine of x. So now you have just proved an identity from section 5.1. In B, I'm going to use the difference of signs formula. So I put the sine of a sum or difference formula up here. Notice in the sine version, you use the top symbol, which are the same, or the bottom symbol, which are the same. So there is no sign switch with sine. Sine. So now, the sine of pi over 2 minus x can be expanded using our formula as the sine of pi over 2 times the cosine of x minus, using the same symbol, the cosine of pi over 2 times the sine of x. Again, from the unit circle, I know that the sine of pi over 2 is 1. Cosine of x minus cosine of pi over 2 is 0. 0 times the sine of x is going to be 0, so I'm just left with the cosine of x equals the cosine of x. Yet again, I have proved a cofunction identity. Let's prove another one. Let's prove the cosecant of pi over 2 minus u equals secant of u. Now, the reason I put this definition up here, we're actually going to use this in an example later in this chapter, but the directions here say prove the reduction formula. Well, technically all of these have been reduction formulas, they're just using a new term for them. And a reduction formula is an identity that reduces the complexity of a trig function of a sum or difference of an angle and a quadrantal function. So pi over 2, pi, 3 pi over 2, 2 pi, etc. All those all those angle values that land on an axis when in standard form on the unit circle. So I'm going to prove this reduction formula, or cofunction identity is what we have known them as before. Now, cosecant of pi over 2 minus u, I don't know the sum or difference of a cosecant, but I do know that cosecant is 1 over the sine of pi over 2 minus u. And I know the sine of a sum or difference, so I'm going to leave this as 1 minus, and I'm going to use my formula. It'll be the sine of pi over 2 times the cosine of u, keep going, minus the cosine of pi over 2 times the sine of u. The sine of pi over 2, actually, you know what? We've already gone through all this from back here, but whatever, I'll do it again. The sine of pi over 2 is 1 cosine of u minus cosine of pi over 2 is 0 times the sine of u. And then we have 1 over cosine of u, which is in fact secant of u, which equals secant of u.